Good morning, everyone. I want to welcome you to the final day of instruction. Actually, I got a lot of information to disseminate today, and I will advise that you pay attention. I've already put instruction regarding group project submission on Canvas. I will advise that you check. I've opened a group submission port. So you can try to internalize the instruction. And of course, I put this morning. The Office of Class Management has approved a larger venue, for the final. And this is where the final is going to take place. Okay, room 101 Tate Hall. Okay, and of course there is no any change to the date, to the time, except the venue. Okay, and I said I was going to reach out to you on the venue, so that is the venue for the exam. It's not going to be this venue because this it's not well spacious enough for the final. Okay, so I've also I think among other information, so you can see here, I've already opened the group assignment submission port, which is very crucial, 15%. So that's very, very crucial. Like I said, you did not necessarily need any standard report. I'm okay with the slide. Okay, just make sure you internalize or you incorporate all my remarks and suggestions during the group presentation. I really want to appreciate every one of you for doing a very great job. I think I enjoy listening to your presentations. So we started on a very strong note. This semester, I also want us to finish strongly. So I think I've already uploaded. Now, I just upload this very tool, the final practice questions. Okay, the two of them, they're very, very crucial. And I'm going to say this, if you try and get yourself familiar with this very tool, you should be good for the final. Initially, I included multivariate regression, but I realized that we've done an assignment on multivariate regression. Because of that, the multivariate regression is not going to be part of the final anymore. So I think I'm going to open this now. Okay. If you take a look at that, that was what I uploaded. That is a final practice questions. Of course, we're going to have 4 problems that will cut across 4 areas. I need you to pay attention. One of the problems in exam we centered on LDA classification, LDA or QDA, there's going to be, I would advise that you read some theories and also calculation. I needed to pay attention to problem 1 here. is also in your notes. You're working with two groups, and we realize that the random variable S that come from any of the two follow normal distribution. And of course, this question is asking if the respective density of functions are like that, find the expression for quadratic discriminator. So we should actually asking you the ratio. We want to find the ln of the ratio of the two density. Take a look at the first density is giving us that. Multivariate, don't forget. Each population is multivariate. The second one is giving us that one. You can see the difference between this guy and this guy. It's just that the covariance structures are not the same. And where I said, there's possibility if the two covariance structure is the same, that would be LDA, linear discriminant analysis. When they are not the same, that is quadratic discriminant analysis. Whether they are the same or not, we are still going to assume normality. And that was why I was trying to say you cannot link independence or other assumptions with normality. They are on their own. Now what I'm doing here, finally, find the ratio of the CD of the PDF, taking the ln, okay, and eventually arriving at this. Imagine, take a look at this. Arriving at this implies that I'm working on quadratic discriminant analysis, because you can see that the covariance structure is, we have covariance structure, they don't have the same covariance structure. But what if in a situation where they have the same covariance structure, how would the expression going to be? And that would be LDA. So I will advise you to revisit your notes on this. Now, I decided to, in addition to that question, I added another material, okay, for under the LDA, but this time around, please pay attention. This time around, this is the one from R. Okay, the one from R. Now, you can see I walk you through theoretical, because the final is actually testing your theoretical knowledge, your computational knowledge. And you know what? You have this, and the output has already been generated. I don't think there's a problem in exam where I'm going to ask you to use R on a particular data set, except for computation. Okay, something you can also use calculator for. Okay, but for those of you who are used to using R, I'm not going to rule it out, because that's your strength. I'm not going to rule it out. You can use that, that's no problem. But if you take a look at this problem, I've already used R. I generated an output. This is an output. And I have the LD1 and the LD2. I have everything. Take a look at that. But take a look at the question. The first question said, using the coefficient provided, write out the two linear discriminant functions. These are it. What am I using? I'm actually using this guy. Can you see this guy? That's what I'm using. So if I were you, why can't you practice? How do I write a discriminant function from a given output of the ADA? How do I write the discriminant function? It's going to be a linear combination. Okay? It's going to be a linear combination. I just wanted to take notes of that. It's super easy. Okay. Now that question said, what do the prior probability tell you about the distribution of species in the training data set? Okay. This is what it tells me. I'm just going to disclose the percentage. You can see 33 point. Where did I get that from? I'm going to show you right now. I get that from here. It's already in the output. Just for you to be able to identify. Look at that. It's right here. It's right there. So what it tells you, if I were you, say it in percentage by multiplying this by 100. Because this is in proportions. Okay? I'm actually interpreting an output. That's all. Interpreting an output. Interpreting an output. Which is what I have here. Take a look at that. Okay? That's what I have. That's what I have. The probability influence classification when posterior probability are calculated. Okay? Now take a look at that. Now there's another one said, identify which variables have the strongest contribution to the separation along the LD1, along the LD2. You know, when you take a look at, why do I say negative 2.98 as the strongest contribution in the LD1? I need you to pay attention. Okay, if you take a look at this, whenever you want to talk about contribution, you say that in an absolute term. Absolute. When you find the absolute values of all the negative, they're going to become a positive. Please pay attention to that. We're not talking about numerical, term. We're talking about the absolute. Okay, so take a look at that. That's for LD1 and also for LD2. Okay? Now, another question is asking you to interpret the proportion of trace. What does it imply about the separation ability of LD1 and LD2? Now, the proportion of the trace, will tell you how much the variance is being explained by the discriminant function. Where am I going to see that? Very easy. Just come here. Just come to the output. Come to the output. It's right here. Do you see proportion of trace? Also see that in percentage. Okay? So take a look at that. Now, problem 1. I think I've already... Then what are the assumptions? The last question here said, what are 2 key assumptions underlying LDA? And why are they important? Don't forget assumptions of multivariate normality. And don't forget the equal variance matrices. Because we're talking about LDA. What about QDA? For the QDA, there will be, the covariance is not going to be the same. Okay? Does that make sense? Now I'm done with one major problem in the final. Don't forget you're going to have 2 hours. You're going to have enough time. You're also going to be by yourself. Okay? I want you to go to this final with the intention that you're going to finish strongly. Now, I want to go to... I'm going back. I'm done with that. I want to go to another problem. Another problem in the exam was centered on principal component analysis. You know what? Please pay attention. You are not going to use R for this. Now you can see the first problem, no use of R. The second problem here, take a look at what you're giving. And let's see the question. Please pay attention. There's going to be an output, arrow output that I call supplemental handouts. Okay, and the output is going to be here. I'm going to show you where the output is going to be part of the exam. Please, oh my God, look at the output I've generated. Look at that. Look at all what you need. PC1, whatever, that is the output. Take a look at that. The one for the covariance, also the one for the correlation. Everything is already done for you. Everything done for you. But when everything is done for you in the principal component analysis, what are you going to do? Please pay attention. What I'm displaying now, okay, I'm also in the exam. When question comes from principal component analysis, you do not need R, because I've already, provided the arrow outputs. The only thing is answer the question. Take a look at the first one here. Show that summation lambda I, which is a trace, okay, equal, they want to show that the summation lambda I equal to the trace R. Okay, and what we're going to do is you're actually going to square, okay, sum of square of eigenvalues. How are you going to know? Here I'm squaring 1.3323. Where is it coming from? Okay, where is it coming from? Okay, where is 1.233 coming from? Okay, you're actually going to see for yourself. Now it's coming from here. Please pay attention. I'm going to tell you in the exam whether you should use correlation, because the output that I'm going to provide for you will contain both the covariance and the correlation. So I'm going to tell you whether you should use correlation matrix or the covariance. Now, the sum of square of the lambda. The lambda here, that is the standard deviation. Okay? So all of that. So when you do that, you actually, so that is what you are having here. And that will be equal to 6. Why is it equal to 6? We are confirming that should be equal to the numbers of features. How many features do you have? 6. That is how to confirm that, the sum of square of the standard deviation, it must be equal to the number of features. Okay? Now, that one is done. Okay, another question said, examine the covariance matrix. That means they want you to go to the covariance matrix and discuss what relationship you notice between the variables. That's what I write here. Okay, I'm not going to base my result on the magnitude, blah, blah, blah. Of course, the covariance matrix they're talking about, okay, is actually here. The covariance matrix they're talking about is here. When you take a look at this problem now, okay, and you're going to see, you can see the covariance, right? The covariance one, now, this is the one for the core, and this is that. So the covariance matrix initially, you actually, okay, these are the pieces, right? Those are the pieces. Now I'm going to show you the covariance matrix. That would be COV. Do you see this guy? You see COV? You can discuss I want to discuss covariance between X1 and X2. Oh, the one that don't forget, covariance tell us the direction as well as correlation. But covariance cannot tell us the strength of the relationship, of the association. If I want to know the strength of the association, I'm going to use correlation. So there are questions like that. Question like that. Look at this. Another one here. Oh my God. Write the equation for the first principal component. That's why you're going to use the eigenvector. Compute the variance of the first principal component. You can see what I'm doing here. The variance. You can see, because the principal component will come in terms of standard deviation. You know, some of you may be wondering, why am I squaring 41.49? Why am I squaring that? Because they asked about the variance of the first principal component. If I actually go to the output, okay, if I go to the output, you're going to see, what do you see here? The arrow is not going to generate the variance, it's going to generate standard deviation. Can you see that? So if I want to get the variance for the first principal component, I'm only going to square the standard deviation provided. Whatever the question they asked about the variance, I know I'm actually going to square the standard deviation. And that was why that is being squared. Okay? That was why that guy is being squared. Now, you see that? Now interpret the first eigenvector computed from the covariance matrix. Interpret the first eigenvector computed from the correlation matrix. Look at that. The interpretation, because there are going to be two sets of eigenvector, because you have the output that I'm going to provide is going to have a covariance. When you use covariance to generate your principal component, and when you use correlation, take a look at that. Just read all of these. Oh, determine how many principal components to retain based on both matrices. When I say both, based on both matrices, when you use covariance matrix and when you use correlation matrix. Look at that. Okay? Now, one of the reasons why I actually included a good presentation in this course is just for you to have an opportunity again to listen to what we've done before, particularly listening to your colleague. And of course, when somebody was presenting on principal components analysis, and I said, don't forget the threshold. Okay? Now, we have a threshold. If you want to go by eigenvalue, okay, if you want to go by eigenvalue, or you want to go by what I call maybe at least 80%. At least 80%. You can see what I said here. I select the first three pieces based on accounting for 87%. Maybe the first two did not account for up to 80%. Because we don't, even though we want to have a kind of dimensionality reduction, but we don't want to throw information away, just like that. Okay? So take a look at that. Okay, so I will advise that, like I said, I've reviewed two major areas. And the two of them, you do not need our software. The outputs will be given. The only thing you need is, how do I interpret? How do I know